Hello. So welcome to our first video of our remote learning post spring break. I'm going to share with you a little information about our tentative plan so that you know what it is. Of course, I will adapt this plan if it doesn't seem to be working for us. So let me know how things are going and share any concerns or problems that you're having. And also, if there's something that's working really well, let me know that too, because I can try to do more of it. So on Wednesdays, we're going to have live meetings. We had the first ones this morning. The two live meetings are at 9:20 to 10:20, and from 10:30 to 11:30. I have to say, the first one was pretty rocky today. The second one went a whole lot better, so hopefully that bodes well for the future. If it turns out that the live meetings do not go well, then we'll figure out another way to handle it. But I'm hopeful after the second meeting. I was dejected after the first meeting, hopeful after the second one. So at least we're going in the right direction, hopefully. There are also going to be lots of online office hours, and there is a separate STAT051 office hours team in Microsoft Teams that we'll use to hold the office hours. I will be sending out an email with a code to join that team and information about all the different times that those office hours are available. So you can look for that coming soon. Between the Wednesday meetings, one of your jobs will be to complete the assigned activities that we would normally be doing in class. And the thing about that is that you can do them at our normal class time. We won't have an official class meeting per se, but there will be office hours scheduled during all of the normal class meeting times. So if as you're working you have questions to ask or you're having difficulty with the activities, we will be there available to help you during those times. So I do suggest working on them at those times if you can, although I know some people might have schedules that make that difficult. It's not the same when you're at home as it is at school. After you finish each activity in Blackboard, you will submit activity questions. They're just a couple of questions pulled out of the activity that you'll type in your answers for. They're not being graded for correctness, only being noted that you did them. And once you do them, you will be able to see the solutions to those activities and use the solutions to check your work. So again, as soon as you submit the activity questions, the solutions will automatically become visible to you and you'll be able to check your work. We're doing that to keep you actually working on the activities as opposed to just reading the solutions. So please do that. I did make due dates on the questions for Tuesday night before the Wednesday class meetings. However, I encourage you to do them earlier in the week. I just did that to give you as much flexibility as possible. Homework, instead of being due on Mondays, is going to be due on Wednesday nights now. And the first of those will be next week on Wednesday, not tonight. Quizzes will still be due on Fridays as they always were. And again, there won't be one due this week, but next week there will be a quiz due on Friday night. And then the last thing I was going to mention is that the final exam will be online with open notes and no proctor. This is not because I would not love to be able to proctor your exams, but it's because there's expense to the student associated with online proctoring, and also that it's really hard without online proctoring to ensure that people aren't using other resources. So I'm just going to make them open notes with no proctor and trust you to, know that that's the format it's in. Okay, if you have any questions or concerns, feel free to email me, or if you feel like it's something that is not personal to you but is something other people might have questions about also, you can post it in the help discussion board in Blackboard. Okay, so we are going to start chapter 9 this week, which is about introducing hypothesis testing. Before break, we learned about estimation, which was one way of making inferences about what we believe is true in the population. Hypothesis testing, instead of giving a range of sort of plausible values for a population parameter, instead we're evaluating claims about a population parameter. So hypothesis testing is using the data from a sample to assess a claim about what might be true in the population. For example, I have a friend named Eric, and he claims that his bowling average is over 180. Now, 180 is pretty high, so I don't think so. I'm doubting that he's really above a 180 bowler. But we go out, we bowl twice, and Eric scores 170 in the first game and 191 in the second game. So that averages out to 180.5, which is a little bit over 180, but it's not so much over 180 that I'm like really convinced that he's better than a 180 bowler. You know, maybe he's just a 170 bowler who had a lucky game, or, you know, who knows? Anything could be true at this point. I mean, he's obviously a pretty good bowler, but is he really better than 180? Who knows? Okay, but then we can bowl again. After we bowl 20 games, Eric's average is 188 points per game. So at this point I say, well, okay, it would be pretty unlikely if he weren't over 180. It'd be pretty unlikely that he'd do this well just by chance. So yeah, I'm convinced. I think his bowling average really is above 180. Right? So the idea here is that I'm thinking about what I'd expect to see if he weren't over 180. I'd expect somewhere 180 or less, right? And if he's over 180, I'd expect to see more. But how likely is the result to have happened due to random chance if he really weren't better than 180? So this is the kind of idea, this is the reasoning behind hypothesis testing. So in order to sort of start more officially talking about hypothesis testing, the first things we're going to need to do are be able to formulate the null and alternative hypotheses. These are the two sort of hypotheses that we're going to be evaluating evidence against the null and in support of the alternative. And so we have the null hypothesis, which is written with an H sub 0 as the subscript, and that is our hypothesis that represents that there's no change from status quo, and what we observed in the sample was just due to random chance. And this is always written as the parameter that we're interested in, either population mean or population proportion or something like that, is being equal to a particular value. So for instance, Eric's bowling average is equal to 180 could be the null hypothesis in this situation. The alternative hypothesis represents an alternative claim under consideration and is the claim that we're seeking evidence to support. And it's always written as the parameter differing from that null value. So either that it's more than or less than the null value. In this case, Eric's claim that I was trying to see if there's strong evidence to support is that his average is above 180. Here's a second example. There's a procedure called XSort, which is designed to try to increase the chance that a person will have a baby girl if they're pregnant. And the procedure is, got to be tested. And so if we wanted to know if there's strong evidence that people who use XSort are more likely to have girls compared to the general population. So of course we need to know what's true in the general population. In the general population, we know that 49% of US births are girls and 51% are boys. So we're going to try to decide, is there strong evidence that people who use XSort are more likely to have girls compared to the general population. Now, the alternative is what we're trying to seek evidence to support. So anytime we're trying to say, like, is there evidence that, whatever comes after that, like, was there evidence that people who use XSort are more likely to have girls compared to the general population? That is what we're trying to support, so that's our alternative, right? So we could think of this as being that the proportion who have girls is, more than 49%, right? Now notice that I figured out the alternative hypothesis first in this situation, and it's usually easiest to do that because whenever we're looking at a research question, the research question is always giving us the alternative hypothesis. So I write the alternative first. The proportion having girls is more than 49%. There's my alternative. Now, I want my null. My null, remember, is that there's no change from status quo. This would be then that XSort does not change that the chance that a person will have a baby girl. So that would mean that the proportion having baby girls among those using XSort is 49%. Right? So as we look at it, even though it's easiest to figure out the alternative hypothesis first, usually if people list their hypotheses, they list the null first. So kind of think like, as I'm looking at this, is there evidence that people who use XSort are more likely to have girls? My alternative, remember, was that they're more likely to have girls, more than a 49% chance. The null is that they're equal to 49%, right? And these hypotheses are always coming from the research question, and whatever number we have here in our alternative hypothesis needs to match the number that we have in our null hypothesis. As we're thinking about how to evaluate the evidence, we're always trying to decide how consistent the observed result. The observed result would be sort of like what happened in the sample. How consistent is the observed result with what we'd expect to see if the null hypothesis is true? And we want to think about, suppose for a minute that we tried the XSort procedure in 100 pregnancies. If the null hypothesis is true and XSort is not effective, what might we see due to random chance? And we can use STAT051 to find out. If I use the sampling distribution for a proportion, and I set the proportion equal to 0.49, that's my null hypothesized value, I can see, okay, if XSort doesn't work, and I were to look at samples of 1,000 babies, what kinds of sample proportions would I expect to see? Remember that on this axis we have the sample proportion. How many girls out of 100 births? Right? And we can see, okay, if XSort doesn't work, we expect that we'd see about 49% of the births come out female. Sometimes they're going to be a little bit more just by chance. Sometimes a little bit less just by chance, right? But, we see sort of like a range of things that look sort of consistent with what we might expect, like, it wouldn't be that unusual to see results in this range. On the other hand, once we get out here, say, wow, if I saw, 65% or more of those babies come out as girls, then that would be something that, could it happen just due to random chance? Just like, hey, XSort happened to get lucky. Sure, it's possible, right? But it's so unlikely that these kinds of results are going to give really strong evidence against the null hypothesis and in favor of the idea that maybe XORT actually does increase the chance that a baby's going to be a girl. So as we come forward through this week, the first activity that you're going to work on is going to be one that introduces the sort of thinking behind hypothesis testing and tries to develop some intuition about it. The second activity is going to give you practice writing hypotheses, and we will meet up next week and we will sort of review those activities and introduce Chapter 10, where we'll start to talk more formally about how to put a numerical measure on how strong the evidence actually is against the null hypothesis based on a sample. Thanks and have a good day.